Okay, we're going to be looking at conservation of energy, prototype 7. The system is isolated. We have here a mass 1 connected by a cord to mass 2 over a pulley. There is friction between mass 1 and the surface of the table. Mass 2 falls distance height h, and mass m1 moves distance d, and of course d and h are equal. We give the axis and we give the numbers associated with mass 1, mass 2, friction, the final y position, and the initial y position. The system is mass 1, mass 2, earth, and table. It is an isolated system. You're asked to find the final velocity after falling h distance. What is the conservation of energy equation for this system? That's simply that the change in potential energy, in this case gravitational potential energy, plus the change in kinetic energy, plus the change in internal energy must sum to 0. What changes in potential energy? Of course, mass 2 is the only mass that changes in potential energy. It decreases by falling height h. Calculate that change. Change in gravitational potential energy is equal to the final gravitational potential energy minus the initial gravitational potential energy, and that's equal to minus mgh. What changes in kinetic energy? Both m1 and m2, both masses change in kinetic energy, and we must account for all masses of the system that have changes in kinetic energy. Calculate that change. Change in kinetic energy is equal to kinetic energy final minus kinetic energy initial, which is equal to 1/2 m1 plus m2 vf squared minus 1/2 m1 plus m2 vi squared, and summing all masses changing in kinetic energy. What changes in internal energy? Friction. Okay, we have work being done internally between mass 1 and the surface of the table. Calculate that change, and it's simply the change in internal energy is equal to the frictional force times the distance d. What is the complete conservation of energy equation? 0 for the isolated system is equal to minus mgh plus 1/2 m1 plus m2 vf squared plus the term representing friction. Of course, the first term is your change in gravitational potential energy. Your second term is the change in kinetic energy of the system. And the third term is your change in internal energy. Calculate the final velocity squared. We have that the final velocity squared is equal to the change in potential energy minus the change in internal energy. And that quantity is multiplied by 2 and divided over the total mass. Now, plug in the numbers and get a final number. You get that the final velocity is 0.55 meters per second. End of problem.